test is really going to help you as you go through. So this, again, this is day 2 of AP Statistics Exam Review 2020. So I'm going to share my screen with you and show you what I'm talking about. So in the Stats Medic course, so there are 30 of you in there already. You should have already seen the link to that course pop up in your, I've given you that link in your email and on Canvas, and so you should already have seen that link for the statistics review. Yesterday, we went through the introduction, so we basically told you kind of how to use the course and what the course would be about. Now, the diagnostic test is 30 questions, and I can see kind of what you've done by clicking on review. So currently, there are some of you that have completed that diagnostic test. There are others that have not. When you complete that diagnostic test, you want to analyze your results. So after you finish it and it tells you which ones you got right and which ones you got wrong, you would want to either use this PDF or doc or print this out and see how many you got correct in each section and kind of make a note of that. So my face-to-face class already has this printout, and if you're online, then you will get this printout or you'll see this in the Stats Medic course as you go through. So I really encourage you. I know that could seem like a long thing to start with, but I really encourage you to do the diagnostic test and see where you're at, because it will also help you as we get closer to that May 22nd date. Okay, so what we're going to do now is we're going to jump into Unit 1. And Unit 1 is one variable data. And I was kind of working on some things with one variable data, but I wanted to show you exactly what is in Unit 1. So what does AP Statistics say that you should know in Unit 1? And so right here is the list of everything in Unit 1. So exploring one variable data, it starts with just an introduction to the statistics course, just saying what can we learn from data. But the key things that are in there, and I'll kind of go through them really quickly, is the language of variation. So what is a variable? So that's the first one. It's kind of like, what is a variable? So if you don't know or you haven't thought about what a variable is something that measures a subject, something that we're talking about. So it's a measurement type of thing. And then the next section is representing a categorical variable and representing a categorical variable with graphs. So tables and graphs are the next two sections. When we talk about variables, we actually talk about that there are categorical and quantitative variables in statistics. So a categorical variable can be explained by words. It can be grouped by words or different categories, whereas a quantitative variable is often used with numbers, right? It's going to be numbers. So it's like your age or your weight or your height would be a quantitative, whereas maybe the highest degree that you earned in school would be a categorical variable, or the type of car you drive would be a categorical variable. So section 1.5 and 1.6 and 1.7 all talk about quantitative variables. So how do you graph a quantitative variable? How do you describe the distribution? So that's SOX, remember, shape, outlier, center, spread. So how do you describe that? Summary statistics, that would be the mean and then the 5-number summary that we use for box plots, maybe mean and standard deviation to go along with that. Talks about the range, the IQR. Those are summary statistics. And then we want to talk about how we could do some graphical representations. So how we would make a box plot based on that, how we would make maybe the normal curve, which is section 10, and some different things. And then 1.9 is comparing distribution. So if we have more than one, so maybe we have 2 box plots and we have to compare one to the other, or we have 2 bar graphs, or anything where we have to compare multiple distributions to each other. And then lastly is the normal distribution. So if they give you the mean and standard deviation, you know that 68% of the data has to be within 1 standard deviation, 95% has to be within 2, and 99.7% has to be within 3. You also talk about z-scores and start to talk about z-scores in the normal distribution. Remember, a z-score is how many standard deviations you are above or below the mean. So a z-score of 0 would mean that you are exactly at the mean. A negative z-score would mean you're below the mean, and a positive z-score would mean that you are above the mean. So that's how the normal distribution works there. So that's everything that's in Unit 1, exploring one variable data. I'm going to put the link in the chat for you guys let me move my screen over so I can have all this in one section. So the link in the chat for the YouTube channel, so there is a YouTube channel where I'm posting all of these videos, and there is the link. And if you notice on my screen, you see the video AP Statistics 2020 Online Review Part 1. That's yesterday's session. So if for some reason you weren't able to attend yesterday's session, or you were behind on it, or needed to look back for anything, all these sessions, there'll be 13 parts on here that will take us all the way up to exam day. Every session should be uploaded onto this YouTube channel each day, and that way you'll be able to follow along there as well. Okay, so are there any questions before we begin? If you'll go to Stats Medic, we're in Unit 1. We're going to go to Video 1.1, which is Types of Displays. Okay, if you want to click on this, if you haven't already, if you'll print out the notes for these videos. If you're not able to, understand, but they're really nice one-page notes. And at the bottom, you'll be able to write the AP exam tips that they give in the video, and you'll be able to write through some of these things and talk through some of these as you go through. So these are guided notes that take you through each video, and then we'll talk about them as we go through as well. Okay, so on each one it's there. So you need to be at video, so this is video 1.1, and this is Types of Displays. And what I'm going to do is allow my computer to talk, and we'll watch video 1.1. If you will make sure you are taking notes. So the big part we talked about yesterday in exam tips was taking notes. So make sure you're taking notes of this video as we're watching, and then we'll talk about it after we go through. Okay, here we go.
Hi, this is Lindsay from the Stats Medic, and you're watching video 1.1, Types of Displays. In this video, we're going to look at 4 different types of displays you'll need for the AP Stats exam. You need to know about histograms, dot plots, stem plots, and box plots. Now, it's very rare that you'd actually be asked to construct a type of display for the exam. So instead, I'm going to go through 4 different types of questions that you will commonly see on the exam each year. The first one is for histogram. A very common question is that you are asked to find the median or the mean. So for this display, I'm going to start by counting off or numbering off how tall each bar is. This first bar is 7, got 11 on this one, about 5, 4, 2, and 2. Now the reason I'm doing that is because we need to know how many data values we have total. There are 31 total in this data set, so our median is located exactly in the center, which would be at the 16th data value. So as I count up here, I've got 7 in my first bar, so I know I haven't reached the median yet. Through my next bar now, I'm up at 11 more, so 18, which tells me the median is located in this bar between 2 and 3. So our median for this distribution will be between 2 and 3. Now, a very common multiple choice question that we've seen almost every year on the AP exam is a question where you're given a few different types of dot plots and then asked to find which has either the smallest or the largest standard deviation. For this question, we'll find the smallest. Now, all three of my distributions are symmetric, so the mean is located right in the center of all of them. Now remember, standard deviation means really essentially it's the average distance from the mean. So which of these displays has the smallest average distance? Well, we can see distribution A is wider than the other, so this one's going to be out. Distribution B, we're getting closer to the center, but still a little bit farther than distribution C. So distribution C is going to have our smallest standard deviation because we have the majority of the dots right in the center towards the mean. So on the AP exam, when you're given a box plot, often they'll give you multiple box plots and ask you to compare. When you're comparing, you'll usually want to reference your 5-number summary, which includes your minimum, the first quartile, median, third quartile, and a maximum. Additionally, on the AP exam, they'll always use a box plot where they show the outliers, so you don't need to take the time to check your outlier rule or your 1.5 IQR. If there's an outlier, it will be obvious. So on this box plot, I've got my minimum, my Q1, median, Q3, and then a common mistake is people will use this point as a maximum when it's not actually. In fact, my maximum is this outlier. So my 5-number summary is at about 2 for the minimum, 18 for Q1, and then so on. Now we're also asked to give the IQR for the distribution. A very common error that we see on the AP exam is students giving an IQR of 33 minus 18 or 18 to 33. Make sure when you're giving your IQR that you don't list it as an interval, but instead you should have a single value of 15. So the last type of display we're going to talk about are stem plots. Now I know I mentioned earlier that it's pretty rare that you'd have to make a type of display for the AP exam. There was one year, however, where students were asked to make a stem plot. A very common mistake is that students didn't include a key, and they did lose points for that. So make sure if you are asked to make a stem plot, or really any distribution, you've got a title and then also a key on your graph. So we're asked to compare the distributions. So I'm going to start with distribution B. And when I look at this shape, I notice here, if I kind of tilt, I can see this has a right skew. Now, remember, a right skew means that the majority of the data values are at the lower end of our distribution, with just a few up at the top. So when I look at distribution A, this is actually also right skew. It's really easy for students to sort of tilt it and think that this is a left skewed distribution. But remember, we're talking about right skewed distribution, meaning that the majority of the data points are at the lower end of the graph. And so these values up here are smaller than our values down here. So this is also a skewed right distribution. So both A and B are skewed to the right.
Okay, so that was all video 1.1. Does anybody have any questions that they have looking at video 1.1? I'm trying to pull it up. I'm pulling up the paper that I have with me. Does anybody have a question that they ask me here that I can go over from 1.1? I have the course and have it printed out. One of the big things, if we counted that there were 36, or that there were 32, we're looking for that 16th value. So if you started on the right side, you would still get between 2 and 3. If you started on the left side, you would still get between 2 and 3. A lot of people, when we ask find the median, they just say 4 just because it's right in the middle. But the median, sorry. Let me get my audio back. Sorry, you better now, I would assume. Can you hear me better now? Yeah, sorry. I have my phone away because of the video. So the median is basically in between, it would be the 16th. If there's 32 of them, it would be, or 31, it would be the 16th data point. Whereas a lot of people will just look at the middle of that graph instead of actually looking at that 16th, that middle data point, and knowing that it is between 2 and 3. So you need to make sure that you look into the graph and notice also that this histogram is skewed to the right. So it is good to know what skewed left and skewed right means. Skewed right is where we have a lot of our data early on in the left part of the histogram. It's like showing up very early, and then later on it ends up going further. Now, what I wanted to show you also, so you see that this is where our median is. On these dot plots, the biggest standard deviation would be A, because it's obviously the most spread out. The next biggest standard deviation would be B, and then this is the smallest standard deviation. So remember, the mean of all of these, like they said, is right in the middle. That's where our mean is. But what we're looking for in standard deviation is the average distance from the mean. So how far are we away from the mean, and we're able to show that far. In a box plot, like we said, this is your minimum right here at the beginning. Q1 is where the box starts. Q3 is where the box ends. The median is marked by a line inside of the box. The maximum is actually out here, okay? But since the maximum was an outlier, what happens is your box plot then goes to the next biggest number. So that's the next biggest number is about 38. So we have kind of like, we've taken our maximum, we've noted it, but it does go to the next biggest number. If you look at the stem plot, this one is the most common mistake. But if you think about it on a number line, think about 12, 12, 21, 24, 25, 26, 29, 30, 35, 38, 47, 62. If you write that out or think about it on a number line, the 62 is far to the right and the 47. Most of our data is in the 10s and 20s, so that what's happening is all of our data is over here on the left, and it is skewed to the right, if you're thinking about that in a number line basis. Hold on here, I've got something in the chat. For the box plot, would you still use the 60 as the max when solving for the range? Yes, I would. So if it asked what the range was, I would say the range for this one is, and I think they numbered that as like 58 or something. So it'll be 58 minus, it looks like it goes to about 2. So I would still say the range is 56 for that one. But we would say including the outlier if you wanted to, be more specific. But a lot of times, but yes, we can't say that this is our maximum because it's really not. This is our maximum, but we can say that our maximum is an outlier when we talk about the 5-number summary. So everything in this first video just talks about the types of graphs that you may see: histogram, dot plot, stem plot, box plot. I would assume you're going to see that at some point, because if you look at our example question from yesterday, you saw a box plot, right? So these are early topics from Unit 1, but they want to get part of a question. So you remember in the 2 questions, you got about 5 parts in each one. One of those 10 parts is going to be from Unit 1, because we've got to make sure that Unit 1 is incorporated in some way. So one of them is you're probably going to have to analyze or describe the distribution, which would be SOX, shape, outlier, center, spread. You're probably going to have to analyze the distribution of some type of graph at some point in this AP exam. And that's really what we're looking at in video 1.1 there, is the different types of graphs. So as we move to the second video today, and remember our goal today is to go through these 2 videos and then do the Unit 1 free response question. As we look at this second video, it is specifically talking about how you describe a distribution. So shape, outlier, center, spread. So it says SOX plus the context of the problem. So you always want to make sure that you're talking about the context of the problem. Yes, you would use the outlier to describe that the distribution is skewed to the right. Yes, you could say due to the high outlier, it is skewed to the right. So So we're going to talk about in video 1.2, shape, outlier, center, spread, making sure we use the context of the problem when we describe our distribution. And then we're going to take a distribution. It is the number of hours of sleep you get at night, and we're going to use SOCS to describe that distribution. So that's going to be video 1.2. So any other questions from 1.1 before we move to 1.2? All right, if not, I'm going to go there. And in 1.2, so we're going to scroll on through. And 1.2 is describing a distribution. Again, the PDF document you can print off that you see me using is right there. So let's talk about how we describe a distribution, which is definitely, we're feeling that is going to be a question that you will get from this unit. That's one of the very important parts of this unit.
Hello, this is Luke from the Stats Medic, and you are watching video 1.2, describing a distribution. So very important, this topic of describing a distribution, because you will most often see that one of the questions on the free response will ask you to either describe or to compare two distributions. So the first thing that you should know is what will be expected on the rubric. The rubrics have been very clear over the years that the things that need to be included can be remembered using SOCS, where we're talking about shape, outlier, center, and spread, and then you also have to include some context in your response. So let's take a look at each one of these individually and see what choices you have as far as describing these four categories. So when it comes to shape, typically there are three different words that you can use to describe the shape: symmetric, skewed left, or skewed right. The other suggestion that we have is that you use LY words when you're describing the shape, such as fairly symmetric, because it's not likely that the distribution is exactly symmetric. So we say something like fairly symmetric. This distribution I might describe as strongly skewed left. And you see this distribution is skewed right, but not quite as strong as the previous one. And so I might say something like slightly skewed right. So the tip here is to use LY words when describing the shape of a distribution. Now when it comes to describing the center of a distribution, it's likely that you probably learned mean, median, and mode together, maybe even in middle school. Well, the reality is that the mode is not necessarily a good measure of center, because we don't always know where the mode is going to end up. So we don't suggest that as a measure of center. So let's just stick to the mean and the median. Now when it comes to spread, you have a few choices as far as how you would describe the spread of a distribution, including the range, which is just the maximum minus the minimum. Make sure you give that as a single value, that the range is a single value, the standard deviation, and then also the IQR. So the next question becomes, which measures of center should I use, or which measures of spread should I use? And the answer to that depends on the shape of the distribution. So if you've decided that the shape of the distribution is fairly symmetric, then you're going to want to go with the mean as a measure of center and the standard deviation as a measure of spread. Now, on the other hand, if you've chosen skewed left or skewed right, the mean may not be an appropriate measure of center, because you might have some outlier value that would have a large influence on the mean, also would have a large influence on the standard deviation. So in the case of skewed distributions, you're going to want to use the median, which is more resistant to outliers, as well as the IQR, because that's also resistant to outliers. Now, when we get to the last category here of outliers, you do have to know the outlier rules for determining if a value is considered an outlier. I like to say that there are outliers that are way too small or way too big. And so really you're just going from your Q1 and your Q3, and you're going to go 1.5 IQRs towards the outside, and then see if your values are outside of that range. So let's take a look at an example where you might be asked to describe a distribution. So what we have here is we've taken a sample of 10 AP Statistics students and asked them how many hours of sleep they got last night and recorded the data. And the question would say, describe the distribution. Well, we know that we have to address socks plus context. And so you can see that's how I've organized the solution up here. The first thing that you should do when given a set of data like this is to create some type of display. So we've created a dot plot here, and from the dot plot you can see that this distribution is slightly skewed to the left with this possible outlier that's drawing the distribution down to this value of 3. So you can see in the solution here that we've said the distribution of the number of hours of sleep is slightly skewed left. Very important here, we said the number of hours of sleep. This is where we have established context in our solution. And once we've established context once, it is no longer necessary to talk about the number of hours of sleep in the remainder of the problem. Now let's take a look at the center. And because we've described the shape as being slightly skewed left, for the center we want to use the median, and for the spread we want to use the IQR. Now to find the center, the median is the middle value. So the middle value will be between the 5th and the 6th value. Both of those values are 7, and so our median is 7. To describe the spread, we're going to use the IQR, which will require us to find Q1 and Q3. Q1 is the median of the first half of the data. Q3 is the median of the second half of the data. We subtract Q1 from Q3, and we get a very simple value for 1 for the IQR. Now, as far as outliers are concerned, we can see that the only potential outlier here is going to be this 3 on the low end. So we use our formula for a value that would be way too low, and you can see, according to that formula, any value less than 4.5 would be considered an outlier. And so we know that value of 3 is considered an outlier. As a final AP exam tip, on a problem like this, make sure that you know how to input these values into a list on your calculator and then use the one variable statistics function in order to check your answers.
Okay, so with that, I kind of in the chat, I was saying a few things as I was sharing my, as he was talking, but the first thing, so with that, I was sharing a few things in the chat as he was talking, but the first thing that I want to you guys to kind of look at is, if you see here, it said if it is, so we're talking about the shape of the distribution. You never want to say it's normal or it's symmetric. You want to say approximately normal or approximately symmetric, because typically it's not going to be exactly normal. And if you say it's normal or you say it's symmetric, that's like saying it for sure is. Kind of like our faces, you know, they're approximately symmetric, but there may be a little bit difference on each side as we go through, okay? So you want to make sure that you understand that that's what we say in our shape. If something is approximately symmetric, as I said in the chat, then you want to use the mean and standard deviation as your center and spread. And an easy way to remember that is if we're doing a normal distribution, right, a normal curve, what do we use? We use the mean and we use the standard deviation for our z-scores. So mean and standard deviation go with shapes or distributions that are symmetric or normal. If your distribution is skewed in one direction, either to the left or to the right, we want to use the median and IQR as our measure of center and spread. Okay, at any time we can use the range as a measure of spread in addition to these, if you want to kind of strengthen your argument. The outlier rule is very important. Outlier rule is 1.5 times the IQR. Remember, the IQR stands for the interquartile range, which is just Q3 minus Q1. And you can get the upper fence is Q3 plus that 1.5 times the IQR, and your lower fence is Q1 minus that 1.5 times the IQR. When I say upper and lower fence, I mean anything that is outside of those areas would be considered an outlier. If it's on those areas, even on the fence or within the fence, then it is not considered an outlier. And then the context is what your problem is talking about. So when we describe the distribution, we can say the distribution of the number of hours of sleep is approximately symmetric, and then we would be done because we've already used context. So context is somewhere when you're describing shape, outlier, center, and spread, you want to say what the problem is talking about. And you only have to do that once, but you want to make sure that gets in there. And then lastly, I wanted you to remember that the best way of doing this, rather than saying the median's right here in the middle and trying to find the IQR that way, the best way of doing this is to type in your numbers into stat edit. So you would go to stat edit and list one, type your numbers in, and then go to stat calc, one variable stats. And remember, if you go to education.ti.com now or anytime in the next few weeks, you can download a free TI-84 calculator for 6 months, a free trial to your computer. So that was still available the last time I checked. When we're using the calculator, do we still need to get work to show work to get credit? As far as showing work, if I was using the outlier formula, if I needed to know if something was an outlier, I would show what I did. If I was doing the IQR, I would say 7 minus 6 equals 1. But I don't know exactly. There's not a lot of work that needs to be shown here to verify it. You don't want to just type. You don't want to just write what you did in your calculator, but you do want to describe it. I will tell you there's 2 ways of getting this a question like this completely right. You could write it in sentence form and go through all these things, but you could also do what he did and just say SOCS, shape, outlier, center, spread, and just kind of make a bulleted list. So the AP exam doesn't care. The readers don't care whether you're writing in like complete sentences with proper, notation and grammar, or if you're just kind of bulleting and going through and kind of making each little part of the distribution. So either way will be fine. I would always show as much work as I can, as long as time allows for that. I would want to show my work on a free response question so that they know, so that the reader knows that I know what I was doing on that. Okay, so that is 1.2. Does anybody have a question on describing a distribution? I think that went into detail pretty well, and then I tried to follow it up with some more details also. If not, I'm going to move forward. Okay, so the next thing that we are going to go to is Unit 1, Free Response 2015, question number 1. Okay, so it looks like this. If you go into, and I will share my screen on here one more time. If you go into the course and you click over, the free response question number 1 is the very next thing here, and it gives you this question on the screen. I'm going to pull the question up myself and see if we can talk about it a little bit. All right, so in question number 1, it says 2 large corporations, A and B, hire many new college graduates as accountants at entry-level positions. In 2009, the starting salary for an entry-level accountant position was $36,000 a year at both corporations. At each corporation, data were collected from 30 employees who were hired in 2009 as entry-level accountants and were still employed 5 years later. So they didn't get fired, they're still there. The yearly salaries of the 60 employees in 2014 are summarized below. So remember, in 2009, these people made $36,000 a year. This is how much now that they make in 2014. So write a few sentences comparing the distributions of the yearly salaries at the 2 corporations. So what do you notice about, if you talk about in the first one, so a couple things that you should notice, okay? I would say that in corporation A is the median or the median of corporation A and B are both very similar, okay? So the median salary in 2014 at Corporation A and B are very similar, and I might be specific, around, so it'd be just over, what, 50K? Right. So now I've talked about the center here. I would say Corporation A has 2 high outliers making over 70K, while Corporation B has none. Right, so Corporation B doesn't have any outliers there. What about the spread? What do you notice about the spread between Corporation A and B? What about the spread between Corporation A and B from these box plots? Yeah, Corporation A has a wider range. It also has a wider what? It has a wider range and a wider IQR. Absolutely. So a wider range and a wider IQR. So I would say the range and IQR at Corporation A is larger than Corporation B. And then I might show what that is. So the range in A, so A would be about 78 to, it looks like 36. So 78, for A it would be 78 minus 36, which is 42. And for B, the range would be, so I'm talking about range here. For A, the range would be 42. For B, the range would be from, it looks like almost 60, so we'll say 59 to almost 40, 41, so about 18, okay? If I want to talk about the IQR for A, it looks like in A, the IQR is from about 55 to, let's say, 48. And in B, the IQR is from about 52 to 48, maybe. Okay, so if you notice, I've talked about the center, I have talked about the outliers, I have talked about the spread, I have also talked about the context of the problem. Corporations, just saying the money, salary, corporations. In a box plot, you actually can't get the shape in a box plot, but if you had said that the outliers would make Corporation A skewed to the right, that would be okay, but you're actually not going to be tested on the shape when we're talking about box plots because it's hard to get the shape sometimes from a box plot. So let's go to B real quick. In B, suppose both corporations offered you a job for $36,000 a year as an entry-level accountant. Based on the box plots, give one reason why you might choose a job at Corporation A. So what's a reason why you would choose a job at Corporation A? Anybody, you can tell me through chat or you can unmute yourself if you want to. Either way is fine. But why would you want to take a job at Corporation A? What is Corporation A? Yeah, so it's possible to get a larger raise. So you have a chance at Corporation A. Corporation A, you have a chance of making more money, right? more money as shown by the two employees making over 70,000, right? So at Corporation A, you've got a chance to maybe you'll be one of those outliers. You've got a chance of making more money in Corporation A. What is Corporation B? You got to think a little bit and look at the box plot. But what does Corporation B offer that Corporation A doesn't? So there's something about Corporation A that makes it different. It's not necessarily consistency. I understand that. So Corporation B, all of its employees are making, a more consistent amount, but there's something that it offers, and it's not necessarily, it's something about the low salary. What is the lowest, what is the minimum at Corporation A? What is the minimum at Corporation A? If you're looking at this box plot, what does it look like it is? 36,000, right? And what did they start with 5 years ago at Corporation A? 36,000. So what's happened in 5 years at Corporation A to to the employees at the bottom? What's happened to the employees at the bottom? Nothing, right? They've gotten no raise. Every employee in Corporation B has at least gotten a raise, right? So even the minimum is at, which looks like 41. So even the lowest employee that's still working has gotten about $1,000 a year increase. So a reason that you might choose a job at Corporation B is everyone still employed has received a raise, whereas in Corporation A, some are still making $36K. And we can tell this by looking at their minimum values. So I actually graded this question in 2015 from students, and a lot of students got A, and then in B, a lot of students got why you would pick Corporation A, because they saw the chance to make more money. A lot of people missed their mistake. Their only mistake in this problem was part 2. And in part 2, you got to be really careful, because you look at Corporation A and you see that it's still there. The minimum is still 36. And at Corporation B, the minimum is 41. So after 5 years in Corporation B, the lowest employee has still gotten about a $5,000 raise, whereas in Corporation A, after 5 years, there's at least one employee or some that have not gotten any raise at all. So if you want like that guaranteed raise, you're like guaranteed to make a raise. It may not be as much, but we talked about that consistency, right? So like that guarantee that I'm going to get a raise if I stay with this company, then you're going to find that in Corporation B. Now, you may not ever make the big money, but you're going to find that consistency, or that amount, or that knowing that you're going to get a raise. In Corporation A, it's a lot wider range, so you've got a chance. It's that risk-reward part, right? If you're risky, you may feel like, oh, I've got a chance to make almost $80,000, but I've also got a chance to be making exactly what I was 5 years ago, okay? That takes us through question 1. Now, let's go through on here how this question number 1 was actually scored. So let's read how they would score question number 1.
Okay, so let's go ahead and take a look at an AP exam question that would be something that's very typical of what you might see as far as describing or comparing two distributions. So this is question number 1 from the 2015 AP exam. It is my expectation at this point that you have already tried the problem on your own. So let's take a look at the question. Two large corporations, A and B, hire many new college graduates as accountants at entry-level positions. In 2009, the starting salary for an entry-level accountant position was $36,000 a year at both corporations. At each corporation, data were collected from 30 employees who were hired in 2009 as entry-level accountants and were still employed at the corporation 5 years later. The yearly salaries of the 60 employees in 2014 are summarized in the box plots below. Part A. Write a few sentences comparing the distributions of the yearly salaries at the two corporations. Part B. Suppose both corporations offered you a job for $36,000 a year as an entry-level accountant. Part I. Based on the box plots, give one reason why you might choose to accept the job at Corporation A. Part II. Based on the box plots, give one reason why you might choose to accept the job at Corporation B. So what I'd like to do here is first to go through what a model response would look like. And then we're going to actually dive into the rubric so that you can see exactly how this question was graded on the AP exam. So let's start with the model response. For part A, it asks to compare two distributions, and we know very well that that means that we have to address 4 big ideas: the shape, the center, the spread, and the outliers. And then we also have to make sure that we take care of the context somewhere. So you can see here that I've stated that the shape cannot be determined. And this is because we are given box plots here. And with a box plot, you don't necessarily know where the individual data values are within each one of the intervals. And so we really can't say anything overall about the shape. For the center, looking at the box plots, we can identify the median as the value at the center of the box. And you can see that the median value is very similar for both Corporation A and Corporation B. Now also from the box plots, we can see the range as the maximum minus the minimum, and we can see the IQR as the length of the box. And in both cases, we can see that the range in the IQR for Corporation A is greater than for Corporation B. Clearly from the box plot, we can see that Corporation A has 2 outliers that are around 72,000 and 78,000, and B does not have any outliers. Now let's take a look at part B. In the first part of Part B, they're asking us why we might want to take a job at Corporation A. And what I noticed in the box plots was that the maximum value for A was much higher than the maximum value for Corporation B. So I had the potential to earn $78,000 per year rather than $60,000 per year. So I said Corporation A allows the potential to make a much higher salary. And that would be a good reason why I might choose Corporation A. In the second part of the question, we're supposed to think about why we might want to choose Corporation B. And what I noticed on the box plots was that some employees at Corporation A were still making the same $36,000 as when they were hired. Whereas at Corporation B, the minimum value has increased from $36,000. And so the advantage of Corporation B is that it seems to guarantee that you will get some sort of a raise from your starting salary. So now let's take a look at what the rubric says for this particular question and what exactly was needed in order to get full credit. So there are 2 parts that need to be graded on this rubric. Part 1 is Part A, and then the second part is Part B. In Part A, there are 4 components that must be satisfied in order to get full credit. The first component is to compare the center. Well, if we take a look at the model solution here,
I'm going to stop that at this point. If we compare, so when we're looking at this, if we compare the center, if we compare the spread, if we talk about the outliers that are in Corporation A, and we mention the context of the problem, which means money, salaries, or the corporations anywhere, then we will get all 4 parts of Part A, and that will give us an E. And E means essentially correct. So for Part A, it would be scored essentially correct. If you only get 3 of those 4, then it will be scored as partially correct. And even if you get 2 out of the 4, it's going to be scored as incorrect because you've missed too much, 0, 1, or 2. In Part B, they want you to say that Corporation A allows you to make a higher salary, but they do want you to mention how you know that. So what is the statistical measure? Well, it's because the maximum or that high outlier in Corporation A is higher than the maximum for Corporation B. So there's two parts there. It's saying that Corporation A allows you to make a higher salary, but then it's saying why, how you know that from looking at the box plots. In part two, it's saying that Corporation B will allow you to get a raise, but then showing how you know that. So you know that there are still, because the minimum value for Corporation A is still $36,000, you know, some employees haven't gotten a raise at all, and because the minimum for Corporation B is over $40,000, you know they've all gotten a raise. So it's also the explanation there. So if you just gave the two answers and didn't explain anything, you would get 2 out of the 4 parts, which would be a P there, okay? If you explain everything and give the answers, you would get an E, and then a 0 or 1 of those 4 things would be an I. So again, as you go through this, an E and an E, and I was going to scroll forward, an E and an E means you would get a 4 on this question. So questions are scored from 0 to 4. A 0 means you didn't even attempt it or you got nothing right. An E and an E, so an E on part A and an E on part B would mean you get a 4, essentially correct. If you get one part essentially correct and the other partially correct, you get a 3. If you get one part essentially correct and the other one completely incorrect, you still get a 2. If you get both parts partially correct, you get a 2. And then if you only get one partial somewhere, that would be a 1. And notice how they score these: minimal, developing, substantial, and complete. Okay? And so what you're hoping for is in each part to get at least a partial and hopefully an essentially correct in some of the parts. But notice that you can still make an average score. So a 2 is an average score that you see if you get one part essentially correct and miss the entire other part. So the way that translates to this year's exam is that when there's 5 parts on a question, you may get 3 of them essentially correct and not know the other 2 parts, and you are still able to make an above average score on that question, okay? So that is how that would transition if we get to that point. So what we've done so far, I'm going to share my screen with you. What we did today, if we go back, we have completed video 1.1, video 1.2, free response question 2015 number 1, and we've talked about how we score that. So we've completed those 4 things. And so now what we're going to do tomorrow when you come back, you don't have any homework to do with this course. All I need you to do is try to go back and complete that diagnostic test if you haven't already. But what we'll do when we come back tomorrow is, as a group of us, if you'll all come back tomorrow, we will go through and talk about these 10 multiple choice questions. So I don't want you to do them beforehand. I want us to kind of dive into it and talk about how we would do those tomorrow during the course. Then we're going to do a free response practice question as well. So we're going to do 10 multiple choice questions, a free response practice question, and then kind of go over how that would be scored. All right, so there won't be any videos as far as notes. We've already taken the notes. We've gotten that part. Now we're going to dive in tomorrow to that key material in Unit 1 that's going to be covered that we mentioned today is what we'll dive into tomorrow. So I thank you for your participation and for following along today, and I hope that you'll join us tomorrow at 10 a.m. And if you have any questions, you can leave those in the chat.